All right, well, hello, physical science students, and welcome to this video lecture by yours truly, Mr. Welch. This video lecture is going to briefly review momentum, and then it's also going to introduce more formally this idea of conservation of momentum, or as I like to abbreviate it, COM. So, momentum. We said that if an object is moving, it has momentum. Okay, we say that momentum is mass in motion. So if an object is moving at 30 meters per second or 2 meters per second, they both have momentum, but maybe different amounts. Okay, so our mathematical definition for momentum, we said that momentum, remember it's this Greek letter rho, is equal to mass times velocity. Now our units for momentum, because we're multiplying mass and velocity, our units for momentum are just our units for mass, kilograms, times meters per second. Okay, so nothing too crazy there. Now, we also discussed last week that we can have a change in momentum. Okay, and that change in momentum, or that change in the motion of the object, what we found out last unit, is actually caused by a force being applied to the object. So, we can have a change in momentum because a force is applied over a certain period of time. And we call this impulse. Okay, we call that impulse. Now, because of that force applied over a certain period of time, we have a change in the motion of that object. So, change in momentum then is also equal to mass times a change in that object's motion, or a change in its velocity. Now I want us to remember that if we ever have a change in something, it's always final minus initial. Okay, so change in velocity is going to be velocity final minus velocity initial. Now understand, we have change momentum is equal to force times time, and we have change in momentum is equal to mass times a change in velocity. So we have a big idea equation here for this unit, and we say that force times time is equal to mass times a change in velocity. Okay, so we'll be utilizing this equation quite a bit in this unit. We're going to be bouncing around between, impulse and momentum and conservation of momentum, but it's important that we understand that momentum is equal to mass times velocity. We can have changes in momentum because of a force applied over a certain amount of time, and because of that force, we have changes in velocity. Okay, so now the next slide is going to be going through conservation of momentum and giving you a brief introduction to that. All right, so conservation of momentum. In that PhET simulation that you were working on today, we were just colliding objects into one another, and a really simple example that we started out with was we had two objects of the same mass. Okay, so each have a mass of 2 kilograms, we'll say, but slightly different velocities. Okay, so what's going to happen here when these two things collide? We can almost think that the momentum of this guy gets transferred to this guy. So what you should have saw today was that the blue guy here, it started to move in the opposite direction it was going at the velocity that the green guy was going. Okay, so it started to move leftward with that velocity of negative 1.5 meters per second. Now the green guy began moving to the right with a velocity of 1 meter per second. Okay, so really what we can kind of look at there is that, like I said earlier, the momentum that our blue object had here essentially got transferred to this, and then vice versa. The green guy transferred his momentum to the blue guy. Thus, velocity is essentially just getting flip-flopped. Now, when we think about conservation of momentum, we need to look at stuff that we have initially and stuff that we have finally. So initially, in this system, we had these two objects, okay? We had these two objects, so they have some initial amount of momentum together, okay? Because remember, we summed those momentums together. So we have some initial amount of momentum here. Well, what we found out today was that we have that same amount after that collision as well, okay? After, I should put final, okay? So we have a mathematical expression for this. We can say that momentum initial within a system has to equal the total momentum final. And that's always going to hold true no matter what type of collision we have. We're going to talk about different types of collisions here, but the amount that we have initial always has to equal the amount final. And now it might be a little confusing when I'm saying initially and finally. What I mean by that is essentially before a collision and after a collision. Okay, that's where we're getting this initial and final from. Now for this particular scenario, we can extend this expression out even further, and we can say that, well, our total momentum initial was the momentum of the blue guy and the momentum of the green guy. So we could say momentum of blue initial plus momentum of green initial. And those two summed together had to equal the momentum of blue final plus momentum of green final. All right, so I know that this probably seems a little bit complex right now, but really the big key that we need to understand with conservation momentum is that whatever amount we have initially, okay, in that system, we have to have the same amount finally. And we just need to be sure that we understand that we need to consider whatever objects are in that system initially and finally. Okay, so we're going to expand upon this in the coming days. This is just kind of a brief intro to conservation of momentum for you, and then a recap of impulse and momentum. So take care, physical science students. Have a good night.